Okay, we're looking at PrepTest 65. This is Logic Game 4. A television programming director is scheduling a 3-hour block of programs beginning at 1 p.m. The programs that are to fill this time block include an hour-long program called G and 4 half-hour programs R, S, T, and W. The programs will be shown one after the other, each program shown exactly once. Okay, so far what I know, I've got a sequential game. I know that each thing can only occur once, and I know that they all have to occur. What I do know is that this one is twice as long, okay? It's twice as long as the other two. So I can put a circle around that, okay? Or to help myself intuitively, I might be able to think of this, you know, like okay, it takes up 2 spaces, all right? Even though it's one program. I mean, that's going to be what eventually is intuitively awkward about this game, is understanding how to manipulate that, okay? Okay, so let's move forward. The schedule must meet the following constraints. G starts on the hour rather than the half hour, okay? So G I'm just putting as 1. It's kind of cryptic right now. It's really could be like 1, 2, or 3. However, I'd like to let myself know that, but I know that G must fall on the beginning of the hour or the top of the hour. Okay, the second rule says that T falls on the second half of the hour, or the half hour rather than the hour. Okay, and the third rule says R is before S, and so now we're getting a little bit easier with regard to the rules. These two should throw us off. This whole little concept going on right here is intuitively awkward, and we need to pay attention to it and be thinking of, you know, how we're going to deal with it, okay? And then the last rule, if W is before T, then W must occur immediately before T, okay? And then if W is not immediately before T, we know for a fact that T has to be before W. Okay, so when we're thinking about this, we've got 5 programs, okay? But really, we have 6 slots, okay? So the slots should be thought of like this. Okay? And that being the 1 o'clock slot, 2 o'clock slot, 3 o'clock slot, okay? And so we really have half-hour slots, and there are 6 of them, and we just have 5 variables, okay? And these 5 variables, one of them is actually twice as long to get us back to 6. And that's really the crux of the game. Once we understand that and we can deal with it, it actually becomes quite easy to deal with this game. So the first thing we need to do is just think about, you know, we need to think about the hierarchy of rules, okay? And what we really have is we don't have a first order rule per se right now, okay, but we do have a block. We know that G is actually 2 because it's 1 hour long, and it can only occur at the top of the hour, okay? So what it means is that G can only do that's the only locations that G can be. Okay, so we've got 3 spots for G. We've dealt with this rule. This rule is done. Okay, let's look at what rule should we apply next. Okay, so I always kind of lecture about the hierarchy of rules: first order rules, second order rules, third order rules, and I do my best to try to show you know, when they directly occur. We can see it says T must occur in spot 1. Okay, or T can either go first or last, okay? But here we have an indirect first order rule, and it really happens after we apply this G, and it says that T has to fall in the second half of the hour. Okay, well, if T has to fall in the second half of the hour, once we've placed G, T can only occur in 2 spots, okay? So I know automatically exactly what T can do, and that's it with regard to G being right here. Okay, when G is here, T can do that. Okay, and then when G is in the last spot, T can do that. Okay, so I know exactly what's happened with T. That's all. This rule is done. Okay, so now I have these 2 rules that tell me this is a third order rule. R is before S. We have 3 variable locations, so we could flesh it out if we wanted to, but it would really open up too many scenarios. It would be inefficient. But we need to think about this rule. If W is before T, then W must occur immediately before T. Well, where do we know for a fact that W is before T? That's all we need to ask ourselves. And it happens here, here, and here. No matter what happens, W will always be before T in these examples. So we place W immediately before T here, here, and here. Okay, and then we can just fill these out. We also know that R is before S. So that's done. This is done. And this is done. Okay? So we've really wholly solved half the scenarios, and with the other half, we just kind of need to understand what's happening. Let's just think about what's going on with these 3. The first thing that I would think about in this is, okay, well, I know that R is going to have to go before S no matter what. That's relatively straightforward. But is W constrained anywhere? Okay, so I know that if W is before T, W has to occur immediately before T. So in every one of these, look, if W is here, we've satisfied the condition automatically. If W is here, we've satisfied this condition automatically. And if W is here, we've satisfied this condition automatically. Okay, when W is not in those places, okay, we just know that T has to occur before W. That basically means that W can go anywhere. W can occur in any spot, and we have not broken this rule. And that's all we're really concerned about. So all we need to know about these 3 is that R is before S, okay, and that W can go anywhere that the others are not going. And so we're ready to proceed. We've taken what I would call an intuitively awkward game and wrestled it under control, and all we need to do is remember that in 3 of these templates that R occurs before S. That's the only thing that we really need to know. So with that, let's go to the questions. Okay, which one of the following could be the order in which the programs are shown from earliest to latest? Okay, so again, we know we've got a list question here. The eternal concept is that we go through each of the rules, we figure out which answer choices break those rules, we eliminate the wrong answers, and the last answer standing is correct. We really never solve this question. What we do is figure out what's wrong with 4 of the 5 answer choices. Okay, so this is just kind of an advanced concept and something that I want you guys to pick up on. This is somewhat hard for us to identify with, because really what happens is, depending on where G is, it kind of changes what, like for example, R is second here. Okay, it's confusing for me to even explain it. R is the second program here, but in the exact same location, it's the 3rd program here. So we want to forego the first 2 rules because they're confusing to us. Now, if you don't do that, it's okay. But if you recognize that and you look at the 3rd and 4th rules first to eliminate answer choices, then it's easier. Okay, we want to look at rules that are easy first. However, it's not absolutely necessary. It's just a small shortcut. It can be solved really either way. But so let's go to the 3rd rule. We just need to know that R is before S. And if we look at that, it's very easy to see that E is done. E is out. Okay? Okay, and then let's look at the 4th rule that just basically says that W is before T, W has to be right next to T. And if you look at D, W is before T, but it's not right next to T. Okay? So now we're down to A, B, C. We can move back to understanding that G has to occur at the top of the hour. Okay, well, if we look at C, all right, R and T, that's 1 hour. W would be an hour and a half, and then G is now occurring at the bottom half of the hour, okay, into the to the top half of the 3rd hour. That is cannot be, because G has to start at the top of the hour. So C is eliminated. We're just looking at A and B. And now we just need to understand that T has to start at the 2nd half of the hour. And if we look at A, we have G and R. We have G, which is the 1st hour, okay, and then so R and W, which are which comprise the 2nd hour, and then T actually would fall at the top of the 3rd hour, so A falls out, and we're left with the correct answer being B. Okay, so even as I explained that to you guys, it caught me, it threw me for a loop. So understanding that to apply those latter two rules first, the ones that are not confusing, that you can eliminate answer choices very quickly, really helps us. And when we get down to 3 answer choices and we have these 2 rules, it gets closer to shooting fish in a barrel than if we have to apply these rules to 5 different answer choices. Okay? All right, let's look at the question 18. If W is the first program, then how many orders are there in which the remaining programs could be shown? Okay, so the question is where can W occur third? I mean, where can W occur first? It can occur first at the 3rd and the 5th, and only that. Okay, and once we know where W occurs, we know for a fact that both R and S have to, according to this rule, R and S have to be, R has to occur before S. So only 2 things can happen. We know that if W is first, then basically G and the RS block can flip. And there's only 2 things that can happen, therefore the answer to the question is B. 19, if R is the second program, then each of the following could be true except. Okay, so where, we just ask ourselves, okay, where can R be the second program? Okay, well, it can be the second program here and here. Okay, now, depending on how you want to do this game, right, how much confidence you have in yourself, you can keep in your mind, if you can keep in your mind that R is here and that you just basically have an option, a dual option for W and S, if you can keep that in your mind, you're free to move on. It doesn't hurt if you need to see what this looks like to go ahead and write it out. And you would just basically go right next to the test pad and just say, okay, I want to see so I know for sure. I'm going to place R here and T here, and basically what will happen is this. Okay, and so now I know that I'm just looking at this. Okay, so if R is the second program, each one of the following could be true except A. S is the third program. Okay, well, because S could be the third program, it cannot be the answer because it's asking us what cannot be true or what could be true except. Okay, so that could be true, therefore it is not the answer to the question. Let's look at B. S is the fourth program. Well, we know that it could happen right here, so that could be true, therefore it is not the answer to the question. Let's look at C. T is the fifth program. Well, that happens here, therefore that is not the answer to the question. D. W is the third. Well, we know we have S as the third here, and T is the third there. Therefore, W could never be the third in a situation where R goes second. As such, we know for a fact D is the correct answer to the question. Let's look at E, though. W is the fifth program. Well, we know for a fact that it could happen right there. Okay, so again, we've proven to ourselves that D is the correct answer to the question. Let's look at 20. If S is the third program, which one of the following must be true? Okay, well, let's just ask ourselves, okay, where can S be the third program? S can be the third program here, okay? And S can also be the third program right here, okay? So basically you could, if you're clever enough and you have the mental stamina, know that you have R here and S here and W here. However, I would personally, if I'm working on the LSAT, I would go over here and just make this out real quick because I don't want to be thinking too much on this test. I'm already having to concentrate on everything else. I really just don't want to make a stupid mistake. So I know that I'm looking at that. So I'm looking at these two. This one and this one. And so if S is the third program, and notice that what's intuitively awkward is this is kind of in the fourth spot and this is kind of in the third spot. Well, that's why we've circled G. I mean, it helps us along to know that this is now the third and this is actually the third, okay? So if S is the third program, then which one of the following must be true, okay? Well, if we look at this right now, right, we know for a fact the only thing that we know must be true. The fourth program, that's the same. W is the fourth program. Okay, this is fourth here. This is the fourth program there. We know, let's see, we know that we've got S third, but that's kind of a given. Okay, so that's also the same. That's the same. But that's where the similarities stop. G is last here and first here. T is second here and last here. And R is first versus second. Okay, so if we know that, we can just go right down to E. W is the fourth. That definitely must be true. Okay, so again, it might be a quicker way for you to look at it, rather than mechanically going through every one. I suggest that you do that. It just depends on, how you feel about your timing. You should be there to where you can go through it. But again, we know for a fact that if we look at this, we can find that W is the same. But let's run through them. A, G is the first program. Well, we know it could be the last. B, R is the first. Well, we know for a fact it could actually be the second. And then C, R is the second program. Well, we know that it could be the first. And then D, T is the fifth. Well, here G is the fifth, so that doesn't have to be. We do know for a fact, though, that E actually must be true in both cases. W is fourth. Okay. All right, let's go to the next question. If G is the third program, then which one of the following could be true? Okay, so we just need to look and say, okay, well, where is G being the third program? Well, G is the third program right here. Okay, so what could be true? Well, we need to know that R is before S here and W can go anywhere. All right, now I'm not as interested in coming over and making another template here because there's a couple of different things that can happen here. So I'm okay. I'm just going to leave it as is and work from memory here, okay? So if G is the third program, which one of the following could be true? A, R is the second program. Well, we know the second programs are both filled up here, and neither one of those are R, so that cannot be true, and therefore that is not the answer to our question. B, R is the fifth program. Okay, well, if we put R fifth, okay, we know that R needs to be before S, so we know that cannot be the answer to the question. C, S is the fourth. Okay, well, S is second here. First, second, third, fourth, we could put S here, we could put R here, and W there. That absolutely could be true. C is therefore the answer to the question. Let's keep going, though, and look at D. T is the fourth program. Well, we know it's either the second or the fifth, so that cannot be true. And then E, W is the second program. Well, again, we have T and S as the second program, therefore W cannot be. And so we've proven, again, that C is the correct answer to the question. Let's look at 22. Which one of the following cannot be true? Okay, S is shown immediately before G. Well, we've got it happening there, so that could be true. Okay. B, W is shown immediately before R. Okay, so let's think about where can that be. Well, it doesn't happen in any of our known situations. And the only other time that we'd have a WR block, right, would be WR here, here, or here, but we know that R has to be before S in each one of those. So if we put a WR here, we'd have S there. WR here, S here, WR here, S here. Therefore, that cannot be true. That B cannot happen. W will never be shown immediately before R. Therefore, that's the answer to the question. Let's look at C, though. G is shown immediately before S. Okay, so the question becomes, can we put an S here? No, but we could right here. We could put an S right here and an R and a W. So G could be shown immediately before S. Let's look at D. R is shown immediately before T. Well, we could do it here. R could be shown immediately before T, and as long as we had our WS in there, or whichever way, that would be okay. So that could be true. Again, that cannot be the answer to the question because it's asking us for what cannot be true. And I know it sounds crazy that I always talk like that. I always say things to you guys like, that could be true, therefore that cannot be the answer to the question because that's asking us what cannot be true. Well, let me tell you, when I took the LSAT, that is the way that I was always thinking. You don't want to mess up on what a question is asking you. You might actually know the answer and say the exact opposite thing. So you always want to be mindful of what the question's actually asking. And let's go to E. T is shown immediately before W. Okay, well, sure, we could do it right here. T could be immediately before W and then an R and an S. Therefore, since that can happen, that cannot be the answer to the question. Okay, let's look at 23. Which one of the following, if substituted for the constraint that generation starts on the hour rather than the half hour, would have the same effect in determining the order in which the programs are shown? Okay, so this is the substitution question. It's immensely popular now. It appeared earlier and then it kind of faded out and now it's back in full force. I want to tell you that there's just a methodical way to solve the game or to solve this question, and it's, you know, the way that I would describe it is when you go through the answer choices, you want to see if any of them just break the known scenarios that you have. And if they break what you have, they cannot be the answer. So the first step is to go through and see what actually breaks a rule to what you've created. Those can be automatically eliminated. Typically, there's either 2 or 3 left after that, more likely 2. And then you've got to actually kind of like either build a hypothetical or you can see what the correct answer is. So let's start with A. G is not shown immediately before T. So what I'd be looking for is G being shown immediately before T. If I find that, then I know that A can't be the answer to the question, and I don't have that. So that is a potential answer. I'm going to B, okay? I'm looking at B, okay? G is either the first program or the 5th program. Well, G is 1st and 5th, but guess what? G can be 3rd. So that is automatically out. Again, I'm not even thinking about substituting anything. I'm just saying, hey, which one of these funky rules that you're giving me are actually breaking the normalcy that I've established here, okay? Let's look at C. Generation is neither 2nd nor 4th. Well, you know what? That's absolutely right. It's either 1st, 3rd, or 5th. Okay, so it didn't break anything. So that's a potential answer to the question. So now I'm looking at D. If G is shown 3rd, then R is shown 1st. Okay, so if G is shown 3rd, then R must be shown 1st. Well, let me look at this. If G is shown 3rd here, I could have an R, S, and a W. So that actually doesn't have to be. So in other words, it has broken that, okay? That is something that is an additional layering of rules that would actually operate to put more constraints than this game actually has. So therefore, D automatically falls out, okay? And then let's look at E. If G is not shown first, then it is shown later than T. Okay, well look at 4. G isn't first, and it's earlier than T. So that's automatically out. Okay, so I have now eliminated 3. And you know, these are considered to be extremely difficult questions. They're not that bad if you just understand that you just need to go through and just eliminate the ones that break the rules. Okay, so it's almost like really it's kind of in a weird way, it's a list question. I mean, we're just kind of looking at the rules that we've established, you know, via this diagram, and finding out which new rules actually violate that. Well, we got 2 that haven't violated them. And I'm hoping that you'll see already that C is the correct answer to the question. That G can be neither 2nd nor 4th. Well, that's absolutely, if that's the case, if G is either 1st, 3rd, or 5th, you know, this is 5, this is 3, this is 1, then that really does have the same effect as saying that G has to go to the top of the hour. Okay, but let's just say you were like, I don't know. You know, I really don't know about A. I need to understand what's going on with A. I don't see the difference between any of them. Okay, well, you're down to just this blue collar grassroots. Let me try to make this rule in violation of these rules. Okay, and so G is not shown immediately before T. Okay, so let me just put, if I place G right here, that's having G at the top of the hour, right? So it's not shown immediately before. Okay, so then if I placed T here, okay, I'm okay in this. Everything is good. G is not shown immediately before T. That's happening right there. I've just answered that. The question becomes, if I can make this valid according to all the other rules, you know, I could put TW here and then RS. Okay, and so what this is telling me is I just did A, and I made it violate the tenet that G must occur at the top of the hour. So I'm looking to break that. I basically made this rule. I displayed this rule on a diagram, and I proved that if I did this rule, I could actually make G start somewhere else. Well, if you look at C, there is simply no way, if I cannot have G go second or fourth, okay, there is no way. So if G can't start here and G can't start here, and we obviously have a sixth spot here, but it's really not a sixth spot. It's just we have an extra slot open because G is twice as long. Okay, if that's the case, there's no way to make G actually occur anything else than on the top of the hour. Therefore, the answer to the question is C. And I know it took me a while to explain this to you, especially the last question, but I want to be overly explanatory with this. First thing you're looking to do is just find the rules that just break this hypothetical. Then you have to kind of flip it over, and you're saying, okay, well now I want to take the rule and apply it in a way that I'm not breaking, I'm not doing anything, I'm validating this rule, but I'm attempting to make it break this too, okay? So 3 of them are going to be insanely obvious to you. You're just going to be able to see that they can happen. There will be 2 that you actually need to take a close look at. Okay, that concludes Logic Game 4, Prep Test 65, December of 2011. Thanks.